In this video, we're going to talk about exploring transformations of functions. So what a transformation is, if you remember from geometry, is just a movement of a figure. So we're going to be moving some different graphs, and we're going to actually look at the connection between the equation for the function and the graph of the function. And the equation actually tells us how the graph is going to move. So we have these things called parent functions that are the simplest form of a family of functions. So we'll talk about some different ones here down below. But a transformation is just going to change the position, size, or shape of this graph, okay? And so here are some different transformations. F is just representing any function. So what happens here is this A is a vertical stretch or compression. So it's either making it taller or it's going to make it shorter. So it's a vertical stretch or compression. I'm going to add one more thing here too. If negative, it reflects over the x-axis. This value in here is a horizontal shift, and the value outside the parentheses here is a vertical shift. Okay, so we're going to kind of break each one of these down a little bit and kind of look more specifically at each one. So a vertical translation, if it's only a vertical translation, so it'll have some function, and then it'll be plus k. Now k could be positive or negative. So in this example, I have this plus 3. That's going to move this function up 3. Now, what function am I talking about? Well, the most simple form of this function is x cubed, and then the k is that plus 3. So this moves it up 3. This one, so again, the most simple form of the function is just the square root part. So square root of x would be the parent function. And this minus 4, if it's negative, it's going to move it down 4. Okay, so vertical transformations are adding or subtracting a number kind of on the end of the parent function. Horizontal is going to be inside a grouping symbol. So it's going to look like this. Now, something that's kind of unique about the horizontal translation is when it's in the grouping symbol with x, it always kind of goes opposite of what you think. So for this example, my grouping symbol is the parentheses, and it's being squared. So the more simple, I'll write it as f of x again. The more simple version would be without the plus 1, so x squared is the parent function. What this plus 1 does when it's inside with the x is it's horizontal, but instead of moving right 1, this one's going to move left 1. So that's kind of what I mean by it's opposite of what you would think. Plus, we typically associate with right, but it's opposite when it's in the grouping symbol with x. Sorry, that is hard to read. I'm gonna write that a little bit smaller. Left 1. There we go. Okay, so here my grouping symbol is a square root. The more simple version would be without the minus 2, so the parent function is just square root of x. What that minus 2 does is it's going to move it right 2. So inside the grouping symbol with x, it's going to move left or right, kind of opposite of what you would think from the sign. Okay. Reflection, I kind of talked about this up above, but it's if I have a negative out in front of the function itself. So my parent function without the negative here would be just the cube root of x. Okay, and what this negative does for both of these is it's a reflection over the x-axis. And it's the same on both, okay? So reflect over the x-axis. Again, without the negative here, my parent function would just be x squared. Vertical stretch or compression, this also is something out front of the f of x. So this is like a negative 1 out front. This is if I have anything else out front besides 1. So here, this is an a is kind of what we're going to use out here. So some value being multiplied by f of x. So if a is something greater than 1, it's going to be a vertical stretch by a factor of 2. So what that means is all the y values are actually getting multiplied by 2. So without the 2, my parent function would just be square root of x. Here, this is the absolute value of x. That's the parent function. And this time, we have that 1/3 out front. So if it's something less than 1, like a third, a half, a quarter, something like that, it's a vertical compression, meaning it's going to be squished. So vertical compression by a third. So all my y values are getting multiplied by a third. So some kind of rules of thumb is overall shape stays the same. There are times where we might have multiple transformations. And so you're going to do them in this order. So the horizontal shift is always what you're going to do first. How I like to think of this is follow PEMDAS. And I'm actually just going to, I don't even like to refer to it as PEMDAS, you guys. We're just going to say follow order of ops. So what that means is you're going to do the grouping symbol first, then the multiplication, which is going to either be this or this. And then lastly, you're going to do the addition or subtraction outside the grouping symbol, which is that vertical shift. So that's the order we're going to do it in with multiple transformations. Okay, so I'm going to have you actually flip to the Module 1 review, and I'm going to do the 1.8, 1.9 example from here. This is going to look kind of similar to what your worksheet is for homework. So we're going to identify the parent function for x and find its function rule, then describe the transformation of the parent function. Okay, so basically what they're asking me is what is the parent function? So I want to think about what is the most simple form of this equation. Well, it would be without all those numbers, right? The symbol that's here is a cube root, and the only variable I would have is x. So my parent function would be the cube root, I almost said x cubed, cube root of x. Okay, so then it says describe the transformation. So I want you to do this in order. So transformation, remember, think order of operations. So we're going to do what's inside the grouping symbol first. So 1, we would do this horizontal shift, and remember subtraction is going to go the opposite horizontally, so this is going to move us right 6. So we're going to shift the function right 6 first. Second, now I move to multiplication. So that 3 in front is vertically stretching. It's going to multiply all the y's by 3. So vertical stretch by a factor of 3. And then lastly, we do the vertical transformation. So that plus 7 on the outside is going to move up 7. Okay, so that's just parent function, identifying what's the most basic form of that function, and then describe how those numbers are moving it. Okay, so now we're given this function. It says we're given the parent function f of x equals the absolute value of x. So that's the most basic form of this family of functions, and that's what the graph of it looks like. It says sketch the graph of the transformation on the same graph here. Okay, so there's nothing inside the parentheses with x, so it's not moving left or right at all. It is going to stretch by a factor of 2, and then it's going to move down 4. So this multiplies y's by 2, and then this moves down 4. Okay, so here's what I mean by multiply the y's by 2. So let's pick some nice numbers here. So here's a nice number. So right now I'm at 2, 2. So what's going to happen is now this y value of 2 is now going to double. It's being multiplied by 2. So now it's going to be here, but then it's going to move down 4. So I'm going to do this with a couple different points, okay? So let's keep going with this one. So if it moves down 4, it's going to end up right here. Okay, same thing over here. This y value is 2. It's going to be multiplied by 2, so now it's at 4, but then it moves down 4. Okay, let's do this nice easy one, 0. Okay, 0 times 2 is still 0, and then it moves down 4. Okay, let's pick another nice one. That's probably going to move us off. Let's do 1. Okay, so 1, 1. 1 times 2 is 2. Move down 4 gets us to -2. We have the exact same point on the other side. 1 times 2 is 2, but down 4 puts us down at -2. Okay, so let's connect so we can kind of see what this graph looks like now. Okay, so this is our new transformed graph. So it has been vertically stretched. You can see it's been gotten skinnier or taller, right? It's been vertically stretched by a factor of 2, and it's moved down 4. Okay, guys, that's it for this video. Thanks for watching.